So one of the things that we need to realize is that we have this thing called exponents. We're going to do exponent laws, and we need to remember what an exponent is. We've already touched on it a little bit when we did quadratics, but now we're going to have to look at certain things. So anything that looks like an exponent is this: x to the m. Now this part here, everyone in mathematics calls this the base. Everything here represents anything that's risen, that x is risen to, is called the exponent. Now we're going to use those terminologies a lot when we do the next bit of homework. Take a look at the next set of slides and see if you understand what's going on. So what we're going to do right now is we're going to multiply these two. So in essence, you'll notice 3 cubed is going to be basically 3 times 3 times 3, and then we're going to times that by the other 3 times 3. And if you look at this, we end up with the following answer. You look at how many 3's are there, and we write 3 as our base, and we're raising it to the power of 5, because there are exactly 5 3's that are there. So if you look at it, there is a pattern. In this case, what we're going to do is we're just going to add the exponents, which are these things right here and right here, to get our maximum exponent. So in doing so, what we get is the following. So our base is -2, and you'll notice that it's in a bracket. And because we have a 2 and a 4, we just add them together. 2 plus 4, and we get as our final answer something is equal to -2 raised to the 6. Now, the last thing that we have to do for both of these problems is actually compute the exponent. For the 3 to the 5, on the calculator, basically what you need to do is, if I'm trying to do 3 to the exponent 5, what we have to do is we're going to type in the number 3 on the calculator. Then we're going to hit something that looks like y to the exponent x on your calculator, and we're raising it to the power of 5. Sometimes the thing that you're using for your y to the x looks like this, a caret sign. Other times it looks like this, x to the y, and you use that to get your answer. Now, for 3 to the 5, we use that combination on our calculator, and we're going to get the following. 3 to the 5 is equal to 243. And -2 in brackets raised to the 6th is going to be 64. Now, we're going to use the same pattern again with multiplication, but we're going to apply it with fractions again. So you'll notice for 1/2 to the 3rd and 1/2 squared, both of them have a times between them. So what we're going to do is we're going to write our base, which is 1/2, and we're going to raise that to the 3 plus 2, which is the same as 1/2 raised to the 5. Now, in order to do these calculations, what I want you to do is I want you to, if there's an exponent outside the bracket, you must apply the exponent to each of the numbers that's inside. So in this case, we're going to have 1 to the 5 on the top divided by 2 to the 5. 1 to the 5 is 1, and 2 to the 5 is 32, and you write it exactly like that. This problem here we'll take a look at later. What I want you to do is I want you to think about how we can solve it later. and we'll try it again at the end of the lesson. So basically what we learned today for multiplication rule of exponents is this. If we have anything that has the same base, what we have is something that works like this. If I have two variables that have the same base, like this a and this a, and when they both have two different exponents, all we have to do when we're multiplying them is just add the two exponents, as seen right here. Okay, now what I'd like you to do is, on the assignment, just try to use those problems. Now what we're going to do is we're going to explore the division rule for powers. And if you think about this, let's take a look at this first problem. 3 to the 6 divided by 3 squared. I could literally just write it like this. Well, this is equal to 3 times 3 times 3 times 3 times 3 times 3 over 3 times 3. And what you'll notice is that we can cancel out 3's from the top and the bottom. And by doing so, that only leaves us with, well, 3 to the exponent 4 left over, because there are exactly 4 3's that are left in our exponent. So in essence, when we're dividing, all we're going to be doing is we're going to be subtracting exponents. Let's try that with the next problem. So we have -2 to the 7 divided by -2 raised to the 4. So our base is -2. And what we're going to do is we're just going to simply subtract the exponents. So the front exponent is 7 and the second exponent is 4. So when we do our final answer, we're looking at -2 in brackets on your calculator raised to the 3. Punching that in your calculator, you're actually going to type this in as -2, and then you're going to hit y to the x, and then the number 3. And you're going to get, as your final answer, -8. So the rule for dividing powers with the same base is keep the base and then simply subtract the exponents and then evaluate. Now let's take a look at the power of a power rule. When we take a look at the power of a power rule, let's take a look at 3 cubed all squared. So 3 cubed. So let's write this as what we know. We know that when we were doing our math from before, anything squared meant we basically repeated it. So now we've just repeated it twice. So now we know that 3 cubed is the same as this. 3 times 3 times 3 in brackets. And then we're also multiplying by 3 times 3 times 3. But isn't all this multiplication? So this really means 3 times 3 times 3 times 3 times 3 times 3. And our base is 3, and all we have to do is count the number of bases that we have here, and you'll notice that there are actually 6. So if we calculated this, 3 to the 6 would equal 729 when we punch that in our calculator. Now, let's do the same for the next one. If you really think about this, what the rule is we just multiply the exponents. So in this case, for this next problem here, we have -2, and what we're trying to do is we're trying to figure out where these numbers are coming from. So our base is -2, but you'll notice that we have 4, and what we're actually going to do is we're going to times it by the outside exponent. So whatever's on the inside of the exponent is multiplied by the outside. So we get the following result for our new line. So we get -2 all raised to the 8. And that comes out to be 256. So just a quick recap. When you do multiplication, when you do power of a power, so you have an exponent inside raised to another exponent, basically what you need to realize is that when there's an exponent raised to another exponent, we just multiply the two. And now let's continue to the next page. Now we're going to take a look at combining the problem. So imagine you have a multiplication like this. You have a multiplication, but you also have a power of a power. Now, we said anything that was a power of a power. What we did was if I had a to the m, we raised it to the n. So basically we had a to the m times n as our answer. In order to multiply these problems, you have to work on the things that have brackets. Now, in this case, what we're going to do is we're just going to multiply these two together. So what we have on the top and the bottom of this bracket here, what we're going to do is we're going to multiply it through. So we have 1/2 cubed, and then we're going to times that by 1. Remember what I said to you. Anytime we had something that was outside, we had to raise it to the power. So imagine if there's no power on something, imagine there's a 1 there. So what we're going to do is we're going to take that 2 that's on the outside, and we're going to apply it to this exponent and this exponent. And because it's outside, we have to use power of a power. So in this case, what we end up having is 1 squared over 2 to the 4. And now the reason why that bottom one was 2 to the 4 is because we had 2 times 2 as our exponents. Okay, and that came from these two. That came from these two things combining. And so now, for our next problem, sometimes we end up we don't have nice bases to put these things together. So what we do is we just pull them apart like so, and we have 1/2. And the 1/2 raised to the power 3 means we have 1 cubed on the top and 2 cubed on the bottom. And then we times it by 1 squared over 2 to the 4. Now, when you have something that looks like this, if you have numerators that are the same, numerators have same base, we can take those bases and pull them together. So we could literally have 1 cubed times 1 squared, which would eventually end up being 1 to the 4, divided by 2 to the, 2 cubed times 3 times 2 to the 4 is 2 to the 7, which will give us 1 over 128. Your homework for today is page 360, number 1, 3, 4, and 5. Now, most of the questions that you'll see are the ones that you saw on the previous 3 slides. That's it. Good luck.